Today we're starting a new unit. It's on area. First we're going to do area of triangles and quadrilaterals, and then also as part of today's lesson we're going to talk about area of similar figures. As we have had many times in this year, we got a lot of theorems that you have to remember, a lot of formulas in this unit, so please make your flashcards. Here we go. First we're going to start with something that you already know. The area of a square is the square of the length of its side, or A equals S squared. All right, how about if we know the length of the diagonal of a square? Well, we can use this formula. If we know the diagonal but not the side length, we can find the area by multiplying 1/2 times the length of the diagonal squared. For instance, here's how that works. Find the area of a square with a diagonal length of 4 times the square root of 3. Okay, so here's my square, here's my diagonal, 4 times the square root of 3. Now before I knew this little formula, this handy formula I just gave you, we'd have to figure out what the side length of the square is. How would we do that? Well, we got two 45, 45, 90 triangles in there, but we don't have to do that now. All we have to do is say the area is 1/2 times the length of the diagonal squared, and that's 1/2 times, that'll be 16 times 3, so that's 48. So that's going to be 24 square feet. Did not have to find the length of the side of the square. If you don't believe that's true, then go ahead and find the length. How are you going to find the length of the side of that square? You're going to have to divide that diagonal length by the square root of 2, right? We don't want to go to all that trouble. We're going to use these neat new formulas that we're going to learn today. Alrighty, here's the theorem for you. The area of a rectangle. We already know this. Area of a rectangle, base times height. Or you may be more accustomed to hearing it this way. The area is the length times the width. That's okay. Base times height. Okay. Area of a parallelogram is also the base times the height. Now what you got to remember is, if I just know the lengths, let's say for instance that I knew these two sides of this parallelogram were 5 units long, and let's say I knew these two sides were 12 units long, I don't know the height, because remember the height has to be perpendicular to whichever one of those I choose as my base. I could use the 5 as my base, but then I would have to find the height that's perpendicular to that base. So let's see, how would I do that? That's not really something I would want to do. So I've got the height in here. I got to find that height. And how do I go about doing that? Well, we'll see right here in a second with an example. So rectangle and parallelogram, areas base times height. Okay, and I made this note here for you. It doesn't matter which side of the parallelogram you choose as your base, as long as you have the length that's perpendicular to that as your height. So for each parallelogram, what do we got here? Okay, the area is base times height. Well, here's our perpendicular height to this base. So all we got to do is say base is 5, height is 4, so our area is 20 square inches. Remember, area will always be in square units. Okay, and here's one where we've chosen this little side here as our base, and that's okay because we extend that side. That's what I was thinking of doing on that other problem, but I knew there was an example here. So as long as we extend that side and find the length of this height that's perpendicular, we can still just use our little formula that says area is base times height, and in that case this would be 2, using this as our base. Our height is 3.5, so 2 times 3.5 is 7 square centimeters. Okay, so we've done a square, we've done a rectangle, we've done a parallelogram. How about the area of a triangle? We've known this for many years. Maybe you didn't know it was a theorem, but we all know the area of a triangle is 1/2 the base times the height. Right? Okay, but now we have some special cases, and we've got some special little formulas that it will really help you to remember. For instance, if I have an equilateral triangle, I can calculate the area by saying it's 1/4 times the square root of 3 times the side length squared. And all the side lengths are the same, right, because it's an equilateral triangle. So I tend to write it this way. I don't put my 1/4, I just put square root of 3 over 4s squared. I don't know, that just seems a little simpler to me. But they're both the same, right? And if I have a right isosceles triangle, and of course by that I mean these two sides are congruent, that's a right angle, so of course these angles are both 45, then I can calculate that area by using this formula. Area is 1/4 times the length of the hypotenuse squared. The hypotenuse. Not the height in this case, but that h there is the hypotenuse of that right isosceles triangle. So let's do one. Find the area of a right isosceles triangle. Okay, there we go. Right isosceles triangle with a hypotenuse of 5. All right. Well, once again, we don't have to go to the trouble of finding the base and the height because we got this neat little formula that we just learned, and we're going to make a flashcard and memorize it. And we can just say the area is 1/4 times the hypotenuse length squared. So that's going to be 25/4. And let's see, yep, we do have units, so that'll be centimeters squared. And please, guys, if you'd like to prove all these by going in here and finding these side lengths and then using your old triangle area formula, 1/2 times base times height, please feel free to prove it to yourself that these little formulas work that I'm giving you. I promise I would not steer you wrong. All right, how about another example? Why don't you pause here and do this one, and I'll come back and have it up for you. Okay. Find the area of an equilateral triangle with a height of 6 feet. All right, so what I was going to do is use this little formula up here that says for an equilateral triangle, I can find the area by multiplying 1/4 times the square root of 3 times the side length squared. So I need to find my side length. So here's my height, 6, and I know that dropping that altitude there from that vertex gives me a 30, 60, 90 triangle, right? This angle here is 30 degrees. So that means my long side is 6. So over here, I went to find my short side, and I had to do that by dividing the long side by the square root of 3. So I get the short side here is 2 times the square root of 3. That means this entire side length is 2 times that, which is 4 times the square root of 3. So all the sides of this equilateral triangle measure 4 times the square root of 3. So I could use 1/2 base times height, but I'm going to use my new formula I learned, and here it is right here. So plugging in 4 times the square root of 3 for my side length, square it, and then I get 12 times, oops, I messed up, 12 times the square root of 3 feet squared. Don't forget to use the proper units. Alrighty. Area of a trapezoid. Formula for finding the area of a trapezoid. I'm going to take 1/2, multiply it by the height, and then multiply that by the sum of the bases. All right, and of course the bases are the two sides of the trapezoid that are parallel to one another. So here's an example to show you how that works. What is the area of this trapezoid PQRS? Well, I've got the bases, but I don't know the height, do I? Here's the height. I need to drop my height down here. Got to figure out what that is. How am I going to do that? Well, let's see. If I drop that height there, I know that this part right here is going to be 5. Right? Because I made myself a rectangle here. If I do that, that gives me a rectangle. So since this is 5, I know this right here has to be 5. And then this part has to be 2. Right? That makes that little, I got a little right triangle over there. So I got a 30, 60, 90 triangle. That little angle up there is going to be 30 degrees, right? And so I know that the 2 is across from the short side, right? So that means the side across from P, which is our height, is going to be 2 times the square root of 3. Got to remember those special right triangle rules. All right, now I'm ready to go. I'm ready to use my formula for the area of a trapezoid. It's 1/2 times the height, which we just found, which is 2 times the square root of 3, times the sum of the bases. So 5 plus 7. 1/2 times 2 is just 1, right? So that's going to give me the square root of 3 times 12. And I'm going to write that like so. 12 times the square root of 3, and we do have units there, so that'll be meters squared. All right, we've learned a lot already today, but let's do a little bit more. How about finding the area of a rhombus or a kite? Theorem 10-5 in your book says if I want to find the area of a rhombus or a kite, I have to multiply 1/2 times the length of the diameters. So let's see an example. A rhombus has sides that are 10 centimeters long. And I always draw it slanty like this. Of course, remember, a rhombus could be a square. This one couldn't, though, because it says it has a longer diagonal. So 10, let's go ahead and label all these 10. If the longer diagonal is 16 centimeters, so that would be this one, 16 centimeters, what is the area of the rhombus? Okay, I'm going to write my formula. Guys, I put a lot of practice problems at the end of this lesson because I think the more you do, the more it will help you to remember these formulas. So every time you do one of these problems, you need to write the formula. That will help you to memorize it. Okay, so area is 1/2 d1 d2. All right, so I got 1/2. I know one diagonal is 16. I got to get that other diagonal length. How am I going to do that? Here's what I need. I need to know how long this is. Right? Oh, well, I know the diagonals bisect each other. Not that that really matters. Well, yeah, it does, because it's going to help me here. Right? So look what I got here, guys. I know the diagonals of a rhombus are perpendicular, correct? So what do I have? I got a 3, 4, 5 triangle, don't I? I got this side here. Look at this. 8. And then here's the side I don't know. That's what I'm trying to find. And then this side over here is 10. So this would be the 4 side, 4 times 2. This would be 5 times 2. So this would be 3 times 2, which tells me that has to be 6, and that has to be 6. So what I have here is my other diagonal length is 12. 6 plus 6 is 12. Alrighty, so 8 times 12 gives me 96. Talking centimeters squared. So there we go. Same procedure you would use if you're trying to find the area of a kite. 1/2 times the length of the diagonals. Area congruence postulate just says that if two polygons are congruent, then they have the same area. And we won't necessarily need this today, but I think maybe in our third lesson, when we start talking about the area of regular polygons, we're going to need to remember this. So just put this in your back pocket, make a little card, and we'll come back and use that at a later day. Area addition postulate says the area of a region is the sum of the areas of its non-overlapping parts. So for instance, in this example, let's see, if we want to do, okay, well look, I know it's a trapezoid because they're telling me that AB is parallel to DC, but I'm going to find the area by finding the parts and then adding them up. And then what I want you to do is, in your spare time, is to go and I'll do mine on this side, and you come over here and use the area formula for a trapezoid and see if you get the same thing that I do when I do it by finding the area of the parts and adding them together. So I got a right triangle here. I can find the area of that. It's not a right isosceles, but that's okay. It's a 30, 60, 90. That should be easy enough. And let's see what I can make another triangle, another right triangle by dropping this altitude. If this angle here is 135, that means that one's 45 because this is 90 and 135 minus 90 is 45, which means this is 45. So I think I probably have everything there that I need to figure this out. All right, so what am I gonna do? Let's see here. Since the hypotenuse, let's look at my little green triangle now. The hypotenuse is 20. That means the short side is going to be half that. So that's right here. So that's going to be 10. And then the long side, which is this one, is going to be 10 times the square root of 3. All right. Let's look at our triangle on this side. If this is 10 right here, see I'm writing it in green, that means this is 10. And since this is a 45, 45, 90, that means this is 10, which means this little piece right here has to be 5. Right? Because if this part here is 10 and the whole thing is 15, then I got 5 left over. So I got 5 down here. Okay, so now I think I can find the areas of all these little parts. I'll start with the little black triangle on the left. I'll call this 1. I'll call this figure 1. And it is a right isosceles triangle, right? So what's the formula for finding the area of a right isosceles triangle? It is 1/4 times the hypotenuse squared. Well, if our side length is 10, then the hypotenuse is 10 times the square root of 2. So what is that? 1/4 times, let's see, 100 times 2, which is 200. So that's 50. So that area right there is 50. Let's do the area of the rectangle now. The little bitty rectangle in the middle, I'll call it A sub R. It's just going to be 10 times 5, right? 10 times 5, length times width, base times height. 10 times 5 equals 50. And then we'll do the area of our green 30, 60, 90 triangle. We'll call it figure 3 in that whole conglomeration we got there. And let's see what we got. Base times height. So 1/2 times 10 times the square root of 3. The height is 10. So what does that give us? That gives us 5 times the square root of 3 times 10, which is 50 times the square root of 3. So according to this little postulate right here, if I add all those together, that'll give me the total area. And remember, what I want you to do is come back later and use this formula and see if you get the same area. I sure hope so. Area total is going to be 50 plus 50 plus 50 times the square root of 3, which is 100 plus 50 times the square root of 3, what do we have? Inches. Square inches. And I do think if you use the formula for finding the area of a trapezoid, it's going to be a lot quicker than finding the sum of each figure in there. But that's what we did. So you check it out. Okay, now I got a bunch of practice problems for you. As I said, these are really, really straightforward. Much easier, much easier than this one that I just did right here. So I'm going to stop here. I'm going to let you work these problems. I'll come back, have the answers up for you, and then we'll see you next time when we talk about areas of similar figures. All right, your first problem. It has this stray triangle down here, but it really doesn't have anything to do with anything. It just wants us to find the area of parallelogram ABCD. So I'm just going to use base times height. You got to remember the height has to be the one that's perpendicular to the base. So 20 times 9, 180. Find the height of a triangle. You just use the triangle formula, plug in the information given, and I got 6 units. Find the height. find the height. I guess that's right, 6. And then the area of the rectangle, 32, very simple. Area of this triangle, use the formula, 1/2 base times height, got 72. I did do these very quickly, so if I've made an error, please let me know. Area of a trapezoid, 1/2 the height times the sum of the bases. The height is 7. Sum of the bases is 14 plus 620. So I got 70 there. This is not a kite, it's a rhombus because all the sides are congruent. 1/2 D1, D2. So the length of the diagonals are 22 and 16. We got a parallelogram here. The height we're trying to find, we know the base is 6, the area is 60. So I simply have to divide 6 into 60 and get 10. And then finally, we do have a kite here. We're using our formula for area, that is 1/2 D1, D2. And the short diagonal is 9 plus 9, which is 18. The long diagonal is 40. And 9 times 40 is 360 units squared. All right, you better make those flashcards and learn those formulas. And we'll see you next time.